Okay, what we've got here is called Coulomb's law. It's the force between two charges. Charges are measured in coulombs. And K is, as you see here, 9 times 10 to the 9th Newton meter squared per Coulomb squared, completely analogous to the force law for gravity, Newton's law of universal gravitation. The only difference being Q1 and Q2 can have opposite signs because charges can be positive or negative, so you can have forces of attraction or repulsion. It all works out if you use this. Charge an electron here. The definition of an angstrom, 10 to the negative 10th meters, roughly the diameter of a typical atom. So force between proton and electron within a typical atom. Order of magnitude, 1 angstrom separation, okay? And we plug in here, order of magnitude comes out about 10 to the 10th because 9 times 10 to the 9th is about 10 to the 10th. 10 to the negative 38th, it's what you get when you square a 10 to the negative 19th. And you divide that by 10 to the negative 20th, which is what you get when you square 10 to the negative 10th meters. The units come out as much as they do in law of universal gravitation. The meter squared, the Coulomb squared, basically cancel out. And you just get newtons. So you get something in the order of 10 to the negative 8th newtons. If you adjust that for the fact that you got a 1.6 times 10 to the negative 19th, comes out around 2.3 times 10 to the negative 8th newtons. Also adjust that 10 to the 10th down by 10% to make it 9 times 10 to the 9th. And then at the 10 to the negative 15th meter, which is a femtometer, separation, roughly the separation in a nucleus, separation of particles in a nucleus, you get about 230 newtons, which is astoundingly big. So now the question is, what's the condition for an orbital, for a circular orbit of an electron around a proton? Okay? Would an electron orbit a proton in a circle? Well, there's some caveats there because you get down into wave mechanics, but we're going to talk about that a little bit. Okay? But you have an attractive force just like a gravitational force. If it's two protons, they wouldn't orbit, they'd go flying apart. And of course that leads to the question, what's going to give you that 230 Newton force in a nucleus to hold these things together? It's called the strong force, for reasons that should be apparent. It's got to be really strong. Okay? So anyhow, we're not going to get in detail into this, but we are going to look at where the energy levels in a hydrogen atom come from, and it's very easy. Now we start, basically, we've learned to use this law, very easy to use. And notice I didn't use the vectors because I didn't really give these things positions, I just said magnitude of the force, right? If you got specific positions, of course, you get your unit vectors and so forth. Now, come down to orbital velocity of the electron around a proton. What's the condition for a circular orbit?